Welcome to this grade 12 CAP session on least squares regression lines. Today we will look at an example of the relationship between grade 9 mathematics marks and grade 12 marks, and to fit a straight line through them. And the straight line will be called the least squares regression line. So the main objectives for today is to find the parameters a and b in this y equals a plus bx, and to find the value of the correlation coefficient r, and to do two examples of interpolation where we find the y value, which will be the grade 12 marks given the grade 9 marks, and to find the grade 9 marks that will predict a specific grade 12 mark. Obviously, I'm not going to go into extrapolation because any maximum is 100 and any minimum is 0. Okay, so that's our introduction. Let's read the question. So every year the grade 9s have to choose whether to take mathematics or mathematical literacy. 15 learners were selected at random, and the marks as a percentage for the grade 9 report and grade 12 final exam are recorded in a table. Okay, so I'm not going to go into the details straight away, but you can see, for instance, there's 27 and 34, and up here we've got 94 and a 99 and a 91. So a lot of the work we're going to do will need to be on the calculator. So we switch it on and say mode 2 and 2, so that we have y equal to a plus bx as our model. Okay, now we're going to enter all the x values. So I'm going to do x's first and then the y's. It's just quicker. So 27 equals 40 equals 53 equals 55 equals 65 equals 67 equals 68, 76, 79, and 79, 80, 83, 88, 94, and 94. Okay, so we've got 15 marks entered so far, and we know there are 15 learners. Now we can continue with y. That's 34, 36, 42, 42, 57, 71, 68, 42, 70, 85, 76, 93, 95, 99, and 91. Okay, so our 50 marks are entered. This point here is an interesting one, the 79 and 76 and 42, and it relates to this point here, which, as you would obviously know, could be an outlier. Doesn't fall into the normal pattern. Okay, so now we can get all the parameters, the a and the b. So we say AC shift 1 for stat, and we want to do regression, so that's 5, and 1 for a. Now I'm going to store this as well, shift store a, because I might want to do some calculations later on. And that will be a equal to minus 6,54. And now we want to get the b, so we can go shift 1, 5, and 2, shift store b. Now once we've done the AC shift, we don't always have to do it again. It wouldn't matter if you did it. So the b is equal to 1,05. So effectively it seems like the marks go up by 5% compared to for every increase in degree in percentage. Okay, so now we want to see how good our fit is, and we can say, okay, let's do our shift stat 5 and 3, which is our correlation coefficient, and that's equal to 0.88. So and I'm just going to store that under M. So that sounds like it's a relatively good fit, and I just want to plot my line now. So I'm going to start off with my input of x of 20. So 20, shift 1, 5 and 5. Okay, so that says if my input percentage is 20, my Gr12 percentage will be 14. So that will be around there. And let's look at 100%. Let's take 90. And we will use the 90 again. So say 90, shift 1, 5 and 5, and that gives us 87.84. So at 80 it will be 87.84, so almost 88. And we can just draw a straight line through it to show that the fit is pretty good. And you can see there's quite the same number of points below and above. It goes in the same direction, so our line is fitted well. So now we can do some interpolation. So we already did 20 and 90, so I'm just going to use 60 as a further example, and it gives us 56.38, so less, just over 56, and that is as close as you can get. And then finally we want to do some interpolation. Given the final mark, what should the input, the grade 9 mark be? So we're going to say 90, shift 1, 5, but instead of 5 we're going to go with 4 to get the x value, and that will be 92. So we need 90 here, which means it will be our 92. Excellent. So that's an introduction to our least squares regression line. So we've got all the parameters, we can interpolate, and we can understand how good the fit is. Thank you very much.